Hi students, this is Mr. Yao. Today we are going to talk about the second lesson of the last transformation, which is rotation. And in this lesson, we will learn how to identify the rotation, meaning find out the center of rotation, which is the fixed point, find out the direction, and the angle it's rotating. Prior knowledge, two things we have talked about before. First, midpoint, adding the x coordinates and divided by 2, adding the y coordinates and divided by 2. Basically averaging the x and averaging the y. Perpendicular slopes. We have been working with this since reflection, so still the same idea, opposite reciprocal, and we're going to use that in this lesson as well. In the last lesson, we were given the fixed point, angle, and direction of rotation. In this lesson, we are going to use the pre-image and image to find the fixed point, angle, and direction of rotation. We will use midpoints and perpendicular lines to help us. The process is similar to find the line of reflection using perpendicular. So first, same thing, let's talk about the easier one, which is 180 degrees. So please flip to the next page of your notes. Let's talk about 180 degrees first. To identify a 180 degree rotation, first you are going to connect all pairs of corresponding points on the pre-image and the image. And then you are just going to find the point where all of these new lines intersect, because they will guarantee to intersect if it is actually 180 degrees. And you are going to write down that point as an ordered pair, and that is our fixed point. So let's have a look at the process. Here's some examples. Example 5, you need to make sure you are connecting the corresponding points. And again, corresponding points means they have the same letter, like A and A prime. So I'm going to connect A and A prime. If you need to draw the line straight, please go get a ruler. A and A prime is there. B and B prime is there. And C prime is there. And you can clearly see they are going through a single point right there. And that is going to be our fixed point. So let's write down the coordinates of the fixed point. It is -2, -1. Next, we already know it's got to be rotate something about this point is -2, -1. Now we just need to know the direction and the angle. And if you look at it, B is right here, it's getting to B prime. It doesn't matter if this direction or that direction, it is 180 degrees. So rotate 180 degrees about -2, -1. That's number 5. Now you can pause here and try example 6. So here's example 6. Let's do the same thing. Connect A and A prime. Connect B and B prime. Connect C and C prime. You should be able to see they are all going through this point right here, which is the origin. And that is 0, 0. We write the description, rotate 180 degrees, because again, it's straight line. From B to B prime, you can go clockwise or counterclockwise. Either way, it's a straight line, so it's going to be 180 degrees. About, or you can use the word around, either way, about the point 0, 0. So that is rotating 180 degrees, and that's very easy to identify. Now let's go talk about the slightly more complicated one, which is rotating 90 degrees. So please flip back to the previous page. Let's talk about rotate 90 degrees. Identify 90 degree rotation. Doesn't matter if it's counterclockwise or clockwise. That's kind of something we're going to decide at the end. First step, connect one pair of corresponding points on the pre-image and image. And then you are going to need to find the midpoint and the slope of the connected line. So if you recall, for example, here's a point, and that's the center rotation, and this point is being rotated like to here. Something you may not know is if you connect them, if you actually connect these 2 points, there's a midpoint, and the center of rotation is for sure going to be on this line that is perpendicular and is going through the midpoint. And that is actually called perpendicular bisector. That's actually what it is. But just for you to give you an idea, that is kind of what we're going for. That's why we need a midpoint and we need the slope. So you are going to find the midpoint and the slope of this line. Afterwards, you are going to use perpendicular slope to draw another line, which is actually referring to this line right here, through the midpoint. Then you're going to repeat that process for all pairs of corresponding points. Afterwards, you are going to find a point where all the lines intersect and write that point as an ordered pair, and that is our fixed point. So the process is slightly different than the 180 degrees. For the 180 degrees, what we basically did was just connect them, and then without using the perpendicular or the midpoint, we are just going to finding the point. We are just finding the point that's intersecting. So the process is very similar, but 90 degree is going to be a bit more complicated. We are going to need to use the midpoint and perpendicular. And after you find that fixed point, lastly, you just need to decide the direction of rotation. Remember, it's got to be from the non-prime figure to the prime figure, pre-image to image. Now let's see how this works in an example. Here's the example. Let's show the steps again. First, connect one pair of corresponding points on the pre-image and the image, and find the midpoint and the slope of the connected line. So let's do A and A prime, for example. Well, for that line, to be honest, you don't have to find the slope because it is a line that's going through the grid. So we should know, well, A and A prime, they're 6 apart, so the midpoint would be 3 apart, and the line that we need would actually be right here. This is the line. Okay, that's the first one. Next, let's connect C and C prime. They were actually 6 vertical away, 1, 2, 3, 4, 5, 6 vertical and 2 horizontal away. So the midpoint would be 3 vertical and 1 horizontal away, which is right here. That's the midpoint. And again, you can choose to use the coordinates, the formula, to actually find that. So we are going to identify the slope. That is down 1, 2, 3 over 1. So for point C and C prime, the slope is down 3 over 1, which is negative 3 over 1. So the slope that we need is 1/3. So we're going to draw the line up 1 over 3, or down 1, left 3. That's basically we are doing step 2 as well. So let's draw that. Just like that, right there. Next, we are going to do B and B prime. B and B prime is 1, 2, 3, 4 vertical away, and 1, 2, 3, 4, 5, 6 horizontal away. So we know it's going to be down 2 over 3. That's where the midpoint is. And for point B, the slope currently is down 2 over 3. So it's negative 2 over 3. That means the new slope that we need is a 3 over 2. So from here, up 3, 1, 2, 3 over 2 right here, or down 3, 1, 2, 3, left 2. Here it is. We can connect everything, and that is going to be that midpoint. And you can clearly see they are all going through this point right here. That point is 0, 0. So step 3, we repeated for all the pairs of points, and now for number 4, we are finding the point where all of these new lines intersected, and that is where they're intersecting. That is our fixed point. Lastly, we just need to decide the direction of rotation. You can just use one pair of points. So for example, I'm just going to use A to A prime. And clearly from A to A prime is going that direction. So that is going to be rotate. That direction is counterclockwise and it's 90 degrees. So it's 90 degree counterclockwise about 0.00. So that is the process. You just need to look at the steps and try to follow along. If you fully understand it, please pause here and try example 2, 3, and 4. If you don't fully understand it, let's look at another example. Example 2. Same process. Step 1, let's choose one pair of points and connect them. So let's say we are going to do, start with T and T prime. That's not a bad one. So let's start with T and T prime. Connect them. They are 4 vertical and 2 horizontal away, so the midpoint is right here. And for T and T prime, that slope currently is up 2 over 1, so it's going to be 2 over 1. That means the new slope that we need is a negative 1/2. So we are basically doing the first step and the second step. As soon as we found the midpoint and slope, we are just going to draw the perpendicular line that's going through the midpoint. So it's going to be negative 1 over 2, so down 1, to the right 2, or up 1, to the left 2. And I can actually draw that line right about here. There we go. That's the first one. Now I'm going to do the second one. Let's see. Let's use point, well, M and M prime. Wait, any one of them. Let's we can do A and A prime. Connect them. They're actually 4 vertical down, 4 vertical and 4 horizontal away. That means this is my midpoint, which is actually 2 down and 2 horizontal. So for A and A prime, my actual slope is going to be down 1 over 1, so negative 1 over 1. That means the new slope I need is going to be a 1 over 1. So up 1 to the right 1, up 1 to the right 1, or down 1 to the left 1, down 1 to the left 1. I can kind of already see. But I do need to actually draw more to make sure. So that's my A and A prime. Now let's do H and H prime. H and H prime, they're right here. It's quite easy. As if you have horizontal or vertical lines, you don't have to do this because you know if it's currently a vertical line, the perpendicular one would have to be horizontal. And the point is right here as the midpoint. My line is going to be a horizontal line right there. Lastly, I just need my M and M prime. Right here, connect them. They're actually one vertical and 5 horizontal, so it is going to be around here. That is the midpoint. So for M, that's a bit special. I have down 1 over 5, so negative 1/5. That means my slope is going to be a positive 5 over 1. Or I can think it as 2.5 over 0.5. Either way, you can do 2.5, so up 2.5, that's 0.5, 1, 2, over 0.5. So that's a point, or that's a point. And if I connect, again, you can choose to do 5 over 1. You just need to know this point is actually at negative 1.5 and 2.5, and actually do it that way. That's totally fine. But as of right now, as soon as I draw that line, which is step 3 and 4, you should be able to see it is going through this point right here, which is negative 2, 0. So lastly, I just need to use one pair of points, try to decide what is the actual change. So let's do that. Whichever point you want to use, I'm just going to use A and A prime because that seems to be pretty straightforward. You can use T and T prime, any of them. There's my A, there's my A prime. Clearly, I'm rotating this way. That is, rotate 90-degree clockwise and about negative 2, 0. So there's the answer for example 2. Now you should pause here and actually work through 3 and 4. And then I'm going to go through and talk about example 3 and 4. Now number 3, same process. Let's start with E and E prime, or let's go for some slightly easier one. Let's see, L and L prime. 2 vertical, 6 horizontal, so I need 1 vertical, 3 horizontal, that's the point. For my L, my slope is going to be up 1 over 3, so 1/3. That means I need negative 3 over 1. So down 3 over 1, again, over means to the right, or up 3, left 1. There is my line. Next, I can have E, well, actually, I can have my B and B prime. There are 4 vertical, 2 horizontal, so I know this is my midpoint. B currently have the slope of down 2 over 1, so negative 2 over 1, which means I need a positive 1/2. So up 1 over 2 or down 1 over 2, I can actually draw my line. Right there. Okay. Next, I can have O and O prime. Let's connect O and O prime. There are actually 2 vertical, 6 horizontal away. That means my midpoint is right there. So my O has a slope of down 1 to the right 3, so negative 1/3. That means the perpendicular line that I need is going to be a positive 3. So up 3 or 3 over 1. Up 3 over 1 right here, or down 3, left 1 right here. I can draw the line right there. And technically, you actually just need to have 3 points. Even if the question had 4 points, it's kind of guaranteed that the last point will work if 3 of them already work. That's why for a triangle, you just need to check all the points. When it's actually a quadrilateral like this one, you just need to check 3 pairs of points. Now we can clearly see this is the point, which again is the origin. So the fixed point is going to be 0, 0. And description, well, let's actually draw the connecting lines. I can now use E to E prime to check. That's the point that I didn't use. So connect E with E prime right here. From E to E prime is going in that direction, which is clockwise. So rotate 90-degree clockwise about 0, 0. There's the answer to example 3. Now last one, example 4. Let's have a look. Same process. Let's start with A to A prime because that's actually very direct. We don't need to write the slope because that's a grid line. They're 4 apart, so this is my midpoint. That means my perpendicular line is going to go horizontally through the grid again. Okay. Next, I can have my B and B prime. Let's do B and B prime right here. So they are 6 horizontal and 6 vertical and 2 horizontal away. So my midpoint is going to be right there. From B to B prime, the slope is going to be up 3 over 1, which is a positive 3. That means the perpendicular line I need is negative 1/3. So down 1 to the right 3, or up 1 to the left 3. Oh, not 4, left 3. So there is my line right there. Okay, that's for point B. Next, we just need to do one more point. You can either do C or D. C seems to be a bit far away, so let's do D. D is right here, connect them. There are actually 2 vertical, 4 horizontal away, so the midpoint has got to be 1 vertical, 2 horizontal away. And for D, the slope is up 1 over 2, so it's 1/2. That means the slope that I need for the perpendicular line is going to be negative 2 over 1. So down 2 over 1, or up 2, left 1. I can clearly see that is the point that they're all going through, which is right here, negative 1, 1. Now I can again use the point that I didn't use to actually check the progress. So I can connect D and D prime. It's going from D to D prime, so that's clearly clockwise. So rotate 90-degree clockwise about negative 1, 1. So that is example 4. And now that's all example for 90-degree, and we have also talked about 180 degrees. So very last question on the end of your notes. How do I tell if it's a 90-degree rotation or a 180-degree rotation? You can use the orientation of the figure to help you. That's one way to help you. If, like, say, A, B, C, D is kind of in a certain order, if it's changed, like A it used to be on the top, now it's on the right, that means it's 90-degree rotation. So that's one way. Or, if you recall, for both methods, for both process, the first step is going to be connecting pairs of corresponding points. So you can choose to connect all of them. After you connect all of them, if they already intersect at one point, then it's guaranteed to be 180 degrees. If they actually don't intersect at one point, that means it's got to be 90 degrees. Then you actually need to use the midpoint. You need to continue with the other steps to find the fixed point, which again means use the midpoint and do the perpendicular line for at least three pairs of three pairs of points. And then you can actually find out they are going to intersect at one point. That's your fixed point. So again, try to connect all pairs of corresponding points. If they already intersect, it's 180 degrees. If they don't, then it's 90, and then you need to follow along to find where the fixed point is. Now that is everything for this rotation lesson, and that is actually everything that we have, all the 5 transformations that we are going to talk about this year. We will talk about mixed up transformations next lesson, but that's everything for now. Thank you.